All right, hello everyone. I think we're okay to start. If you're wondering about the microphone and why you're not hearing it on the top, it's because I'm recording everything to upload later to MakeTube. We couldn't get one up to access. So today I'm going to talk about a bit about a handy trick in assembly that could help you in your drawing. Then I'm going to talk a bit generally about drawing in third-angle projection. At that point, Josephine will come up here to show you her design project and some points that she wants to make clear, some advice and some things that she wanted to know back then. And after that, we're going to go to the specific details of how to draw on SolidWorks. So first things first, gonna wait for SolidWorks to open my thing. After that, here I have an assembly that I made earlier. I don't think any one of you is going to find it useful for his drawing, which is nice. Alright, I want to just please, thank you, take your attention to this button here, which is under the Evaluate tab, called Interference Detection, which when you press it and press Calculate, it just shows you all the points at which any of the objects intersects one another, which usually will be, for example, where the threads and the bolts intersect. But for example, could be very useful if you're not sure for the circlips. Right there, I have purposefully made the circlip hole too small, which can just highlight it there, which you can then go and fix, which is very handy for last minute checks. Alright, so done with that. Now, under this bearing, just for demonstration purposes, there's a thread. Now, I haven't done this thread in the normal way, that is you under hole wizard and the bounds, because if I do that and then import it into the drawing, the exact thread is going to show in the drawing, which is very ugly and very hard to work with, and since we want to use the simplified projections. So what we do instead is go to Insert, then should be annotations down here, and cosmetic thread. Now, I've already done this, so I'll try to find another place to do it. Yeah, for example, we want to thread that last part. Click on the, yeah, sorry, I will forget. You have to be in part to do this, not in assembly. Right, there we go. So insert, annotations, thread. You press the edge at which you want it to start. Usually the parameters are selected for you, like over here, machine threader and whatnot. This is what is going to show up in your drawings. You cannot edit it now, but you can edit it later, so don't worry about it. And that part over there, which is the texture thread, is what should come, is what probably will not come out to you, because, so if I'm to press check, for this to appear to you, you have to go and change some settings, namely go over here, document properties and detailing. This part over here said that cosmetic threads to you will probably be unchecked. Check it and then you will have that effect. Okay, then assembly. Okay, so you choose to make an assembly, just to be quick, just do an assembly drawing, this assembly. Let's say, let's use the standard one, why not? For that, I don't know what I'm going to pick, let's say this. Okay. I can see that the scale is a bit too small for now, so a quick way, instead of going through the properties or whatever, just to go on here on the bottom and change the thread immediately, and it will change it for the whole sheet. And alright, that's better. Below the title block, which if you press right click and edit sheet format, come on, you can then edit the various fields like revision and drone checked, approved, and a bunch. Alright, now I'm gonna hand over to Josephine, who's gonna show us her her own work and the feedback she gave and some advice she wants to give.
Right, so this is my submission from last year, different project. But I thought it might just be good to see what I did, so just to see an example of a submission and what feedback I got. So my grade was an A, but I did still have stuff to improve on. So what I got was good submission, assembly clear. Then there was a problem with my manufacturing, which it impacts your grade in the drawing, but then it doesn't completely destroy your grade. So with mine, I have a drum here, but I couldn't actually manufacture it because welding was not an option. It's stated in the project brief, but that was okay. Then my keyways were also not dimensioned properly. So I had third angle projection view. That's just the basic stuff you need to get correct. The center lines, the center mark here. And then another thing he said was when you have gears, you need to portray them like this. So what I did was I replaced my gears in the assembly with a cylinder, and then just, I don't know if this is a proper way to do it, but I drew these extra rectangles here, and then I hid the gears in my assembly, so I only had the cylinders. So that's how you can get rid of the teeth in your drawings. Then for the section cut, one thing I did wrong was I sectioned the keys as well. So as you can see here, I did align the shafts that the section cut goes directly through the keys. That meant that my gears didn't completely mesh in the end, but that you can't see from the drawing, so that's fine. So as you can see, yeah, it's on the side here, but they should not be sectioned. So that's another thing, important thing to know, which parts needs to be sectioned or not. And I think that's in the booklet you're given, but Nick is also going to talk about that. Then bearing housings, I portrayed like this, but you can do it both ways, where you have the little circle. So if I now go on to the next one. So here I said break all edges, which was fine because I didn't want to fillet everything else. Then also I said 45-degree all chamfers. So you can say things like that to make it more clear, your whole drawing. And then you need to be careful. You need to be careful about your dimensions. So these two dimensions, this one and this one, they are saying the same thing. So I could just say have one of them and say applies to both grooves. So that makes it even simpler. So you need to see where you can make it clearer to your tutor or whoever is marking it. Also, one more thing I did wrong was that for the section cuts here, for my keyways, I put a dimension which you can't actually measure. So you can't actually measure this to this without measuring the distance from here to the bottom. Yeah, so here to here. So that you also just need to think about. So if you put a measurement, you need to be able to actually measure that. And then tolerances. So here I put G6. Yeah, but a bearing was going to go around that, and it should have been H6 because H6 means that there's no no space between your shaft and the hole. So think about that. I think Graham gave you an app, ISOFITs, that might have been useful. Yeah, so have a look at that sheet. You're giving it a table with the shaft and hole tolerances. That's very important. Yep. Okay. So this was my bill of materials. I found that if you're doing a bill of materials, you need to be really patient, because this last one I actually did then put it into a PDF, because I knew that if I would save it and open it again, it would just completely revert back to its original. So you need to play around with that a little. Nick maybe has an answer to this. At the time I didn't. So what would happen was I changed all of these names and they would revert back. But so my part numbers, you can see they are structured. I tried to structure them with my drawing number, although they're a different thing, but just to make it clear what part you're talking about. So that's important in your second year where you have to do this project. And you have to make drawings for every part that you design. And so when you're manufacturing, you can actually see what part you're referring to. So that's important then. Yeah, I think that was about it. I suppose, is it helpful to see a submission like this, even though it's not the same project you're doing? So would you want to, I could post this if you want to see an example. Okay. Good.
Thank you very much, Josephine. Just a word of warning for some things might have changed this year. For example, ask your tutor whether he wants the names of standard parts in ISO 4 in their classification form or in the descriptive form. Like for example, if there is somewhere an M6 screw, whether he wants this name or M6 times 4.5 20 millimeters long. Ask him which format he wants. After that, you will see as we go on that there are many things that are tutor dependent, so ask your tutor just to be on the safe side. Okay. Please. Alright. Alright. Now have our assembly drawing. 3 views as discussed previously with the third angle projection. If you can imagine it, like if this part is held over, this is turned like this, the same for the top part. And so, alright. So let's say you want to show a specific detail, like for example how the bolts are fastened over here. There are 3 ways you can do that, as far as I remember, at least. Okay, there are more ways, don't worry. So, first way, section view. You take one of basically make a planar cut exactly where you want to cut. Let's say somewhere. Sorry, right here. Come on. Right. Now, if I want to also show these bolts in the same cut to be more efficient with my space, I can click on the option I just did, click the first point, click the second point that I want to extend, then click the height. Press OK and press OK with this by not clicking on exclude fasteners, because in SolidWorks mind fasteners also includes gears. And press OK, we get our extra view. Put somewhere here. And alright, we have an extra view. If I want to also have another detail for the configuration over here, I can just click on detail view. It will let me draw a circle. Draw circles here. then I can show the detail like this and just place it wherever. We'll also get the description, which I should put somewhere here. Maybe I should also. That's better. What else? All right. I need to find a better surface for the mask. Give me a moment. Right, we have the sketch over. We have the section view over here, and immediately, because it was made by SolidWorks, there are several problems. First problem: the hatching is not correct. Let's say, because everything adjacent has the same hatching. How to fix it? Firstly, if we pretend for a moment that this whole thing is a shaft, if we untick material cross section, just click on no hatching, we get rid of the hatching. Same thing for all fasteners. Fasteners include, come on, I won't do it now to save time. Keys are not hatched, bolts, washers, nuts. Am I forgetting something? And circlips. And circlips are a bit weird in that you do hatch them, you just solid hatch them, like this. Come on. Okay. Yeah. Come on. At this view, probably when this was cut out, the circle was in its opening, in its middle. It might be beneficial to just model very small cylinders instead of circlips, because it will help you in your drawing, or just rotate them in such a way that they will appear in section views. What else? Alright, concerning the bearings, it's really dependent on what your tutor tells you. Bearings traditionally are represented like this. They don't have a hatching and you just leave them as is. That's at least what Harmider told in his lecture. JJ in his lecture proposed that we do the following. We sketch over it. If SolidWorks could cooperate, there we go. We sketch over it, we add the cross, that very rough now. The lines, I will explain later why they are so enormous. Mirror this about the center line. Delete this. Then right click on the bearing itself. Whoops, no. I need to remember what. There we go. Hide component. That's how you represent a simplified bearing, only with there we go. That's how you do simplified bearing. You can change the cross for an X if that's what your tutor wants. Ask him which of the two techniques he prefers more to do. After that, all right, gears. Now the gears are a bit more challenging than that. So if I go and open this part, because I dragged and dropped it, it will refer me to the standard part. For now, I can just save as, click the first option, and just save it anywhere. Note that if I close SolidWorks and open it again, it will revert back to the original one. To change it, you have to either save the new part as, for example, .step, which isn't a which is a different editable file, or just hope for the best and delete your gear from your assembly and re-input that you just saved. So what we do is go to this option, which is the teeth, and click on suppress, click on the first tooth over here, click on where is it? Suppress. Now it's a smooth cylinder. Should we go back where is it? Here? The gear itself changes to a cylinder as before. If you're wondering what I just did, this here thing at the rebuild is basically the equivalent of a refresh in a web browser. So, and we have this thing here. It's supposed to be our gear. What you have to do to make it more like the standard is cross out the material crosshatch, select none here, do the same thing that Josephine described with the rectangles here. I will do them very roughly right now, and a center line to indicate the PCD. All right. Just select them, press this to make them almost. I'm not sure why they're gray. I'll check it up later and tell you in the second part. And now that you have this representing the addendum, dedendum, and PCD of the gear, all you do is go back to annotation, click on area hatch fill, select on this and this area, and this is how you do the standard view of a gear. All right so far? Any questions up to now? Yes. I just did them very roughly now, but they should be at with the dimensions of the PCD and the bond. Yes, with the only difference that if this were a pulley, you wouldn't have this line over here. It would all be hatched, and you would just have this center line for the internal diameter. But make sure to ask your tutor about this, because pulleys are not very well covered in the notes we have right now. Anything else? All right, going on. All right. So what about this? All right, next thing, threads. Right now, there should be a thread viewing over here. So let me just check it out for a bit. Oh, perhaps I just didn't save it. It is about 30. All right. Yeah. There we go. Yeah, sorry about that. For some reason, correct me if I'm wrong, but in assembly view, in assembly drawing, SolidWorks does not show the external threads. And I don't know if that's correct or not. Yeah, because like from start, now I'm on an assembly drawing and I have no threads over here where there should be. But if I go back to the... Yes. Which is right here. Like if you see right here, there is a cosmetic that I put it on from previously, but it's not in the assembly drawing. Yeah. Yeah. My problem is that like over here they're shown in the part drawing. They're not in the assembly, and I'm not sure if that's on purpose. Okay, I'll Yeah, I'll check it later as well. So, simplified threads. I showed you before how to input the cosmetic thread. After that, things get a bit tricky because come on. You'll have something like this. You'll put the cosmetic thread and get something like this. But in your drawing, I think it's this one. This is what we'll get. That's a problem because you need this here to be chamfered so that you can also get this line. And there is no clear-cut way on how to do this. You can only sort of cheat your way through it by creating a chamfer roughly the same size as the thread, very roughly, which will then, come on, translate to this. Then all you have to do is go over here and change this one line to make it a bit thinner. Please. This is the correct way of showing simplified threads. How you open this menu, I don't remember. Josephine, how do you open this menu over here for the lines? Define up there. Thank you. Then all right. So we're remaining for a bit in the assembly drawing. So center lines and center points. If you have a circular feature like this one, you add the center point, which here is already added. If you have a straight revolved part, even if there is a keyway, like over here, even if this is not perfectly symmetrical because of the keyway here, you still add the center line. Important point. Over here, and this part won't, but don't worry about it. So should have appeared over here as well. Thank you. Then, all right, dimensioning. So we want to put a dimension, for example, over here, which is automatically 100. All right, and say we want to make it 100 with a tolerance of 0 on the negative and 20 on the positive because of whatever reason. Over here, we choose on bilateral. We let this as 0. We change it at 2, and it should edit itself over here. If it doesn't, you just change this because it might be set over here or to none, which means that it gets hidden. After that, yeah, that's also a bit of a, come on please, a weird point. So let's see if I remember how to do this. There are some, in some instances when you want to add, for example, more decimals on this point, so that it's 100.00, you will have set this on SolidWorks, but it won't do it because there's a hidden option in the settings that limits how much you can, come on, you can show, how many decimals you can show. Do you by any chance remember where that is? Because I've forgotten. The option to show more, come on, the option to show more decimals in a dimension. There's a setting in the like on SolidWorks itself which limits you if you are, for example, 100.00. I just forgot where it is. Probably, yeah, there you go. yeah, trailing 0 from this option trailing 0, you go from smart to show and okay, and now it should appear over here. After that, after that, so we've added our tolerance. Alright. Let's say for some reason you want that geometric tolerance because you want to make sure that this part over here is parallel to this part over here. First thing, you have to add a datum feature to say where you're referring to. No, I clicked the wrong thing. Thank you. So this is our datum feature A. Then person geometric tolerance. Let's say that we want this to be absolutely parallel to 0.03 with respect to A. Let's add another 0 to be proper. Now we get this option, and we'll have to just move the arrow to what we want to mean. And we've just added geometric relation. What else? Alright. You have a keyway like over here. You want to show on a dimension its depth, as Josephine pointed out previously. You can either section it with a plane as we did previously, or if you just want to have a little small detail, you can go to broken out section, draw around the thing that you want to break. Doesn't need to be too much accurate. On depth, just either do it manually, or if you know the dimension, even better. For now, I do not remember it. I just have to brute force my way through it. Yeah, close enough. And I have a detail which, if I want, I can show that this depth is this much. Alright. Right. Two final things and we're done. Don't worry about it. If I want to say dimension specifically for a chamfer, which I think I've forgotten to put over here, but let's just use this one. You don't have to if this is about the thread, but for whichever other chamfer you want. You press on the chamfer dimension once more. You first click the chamfer, then click the line right next to it, and get the reading. Like this. Leave it as is or change the precision as before. Alright, and final thing. If you want to add a note to it to whoever is drawing, like for example that come on. If you had many, for example, come on, chamfers here, for example, and over here and whatever, it is just add a comment that says all chamfers are 1 cross 45 degrees, and it will be just more than fine. If you have, for example, 4 identical horns, you want to call them out very easily and quickly, just click on one of them. And you will have this ready, 4 holes times 9 in diameter, which you can add an uncertainty to, boundary to from here. And if you don't like this because you've never seen it before, you can go over here and change it. Or for example, delete this and write through all, for example. But every time you make a change, you'll get this pop-up. Best thing is just to not show again and okay. Should be in caps, but why not? Alright, have I forgotten anything? I think so. Any questions?